Hello friend, once again welcome on board, and based on request from my friend, today we'll discuss some question about Airbus 320 family and CFM LEAP engine. This is basically important for DGCA B1 assessment. So guys, sit back and relax, enjoy this video till end for complete knowledge. Don't forget to hit the like and subscribe this channel because उम्र को हराना है तो शौक जिंदा रखना है. So let's start with Airbus 320 airframe and LEAP engine question for DGCA assessment. So first we'll start with the LEAP engine. This is CFM LEAP 1A engine. Just demo, you can see the photo of the CFM LEAP engine, and the first question is that what is the function of PSS box? PSS means pressure subsystem. How many connections are there on the PSS box? So first you can see the location of the PSS box, where it is located, and this is your PSS box on the CFM LEAP engine, right side of the fan cowl on the fan case area. Pressure subsystem supplies engine pressure and data entry plug data to the electronic engine control unit. Location of this box, already I have told, this is a line replaceable unit. You can replace in the line, and it's take analog air input and converted into digital signal for both of to EC to control the engines. So this will take analog input data and this will convert into the digital signal for both EC. It's also process the data from the data entry plug to set the engine thrust rating, including two electrical connectors for EC channels. So we'll discuss in next diagram how many connection and connectors are available with this PSS box. So this data entry plug basically depend on when you are going to change the thrust of the engine. Means suppose you are going to install a 320 engine to 321, you have to increase the thrust rating. So you have to use this programming plug, data entry plugs, to set the thrust for the engine. So this is your another part to do signal conversion of pressure system input and communicate with EC. So signal conversion, already I have told, analog to digital. There is another purpose to give the cross channel data link backup. So this will also talk, this is PSS, this will give signal to both channel A, B, and they will cross talk with each other through cross channel data link. And the rating plug, already I have told, 390, 321 thrust bump and N1 trim level can be set through this. Now how many connections are there in the PSS box, and you will see 4 pressure sensor connections are there. P0 intake port measure the ambient static pressure, ambient pressure. So P0 you can see here, this is your P0 sensor. This will measure the ambient pressure surrounding that compartment, you can say. And P12 port measure fan inlet rotor pressure. So P12 sensor is your this fan inlet pressure for P12 sensor. Then P3 port to measure the static discharge pressure from the high pressure compressor. So PS3 is your this. So this will measure the discharge pressure from the HPC. And P3B port measure the booster discharge pressure. This is your P3B port. So P3B measure the booster discharge pressure. And 2 electrical connectors that link with PSS box for channel A, channel B. So this is your electrical connection for EC channel B, and this is for EC channel A. Rating plug, data entry plug connector, you can see this data entry plug. In case of you are replacing PSS box, make sure this data plug same to be utilized for the PSS box. Don't replace with 321 data plug or something. So you have to replace only PSS box, so we'll use same data entry plug. So the next question is, what is the function of start bleed booster anti-ice? So you can see the diagram, start bleed booster anti-ice. This is your diagram in the core area. So this is two functions, single wall control by the EC. EC uses servo fuel to control the booster anti-ice exhaust port to direct HPC 7 stage air to the anti-ice tube. So this will use 7 stage and high pressure air for the anti-ice tube also. Only one EC control the start bleed booster anti-ice wall at any point of time, and this is line replaceable unit located in RS side of the core engine. During the starting, to improve the start performance, the start bleed booster anti-ice valve release the air from the stage 7 of the high pressure compressor to decrease the compressor pressure. The air is released into the core compartment via diffuser. So this is your diffuser, and air will come out through this excess air. So this will also give the best performance during engine start. If you talk about ice, when ice is detected of a concern, the flight crew activated the associated engine anti-ice. The electronic engine control received this order from the cockpit. Further, EC commanded the associated electro-hydraulic servo valve within the splitter control unit and servo valve assembly. This we'll discuss in separate video, to open the start bleed booster anti-ice valve. So this is a way how this will operate. When the start bleed booster anti-ice valve is open, warm air is delivered from the high pressure compressor 7 stage of HPC, the booster flow to the booster flow splitter via the booster anti-ice tube valve. So this is your splitter, flow splitter, warm air will go, and this is your splitter. You can see from the front side of the engine facing forward of the fan blade, you can see this is the splitter. So this is anti-ice, prevent the ice formation to the particular area. So the next topic is, what are the special functions available in the LEAP FEDEC menu. So this is very good to know information about CFM LEAP 1A engine, and this function is not available with all the other engine of 320 family. So special function, if you see, there is a lot of special function: water wash, oil debris, fuel system, hydraulic pump, accidents report, then engine balancing, discrete input, nacelle anti-ice lock, and hydraulic pump. So we'll go through this one by one. So first we'll discuss with the water wash. What will happen during the water wash procedure? So this is your MCDU menu. So you can see caution engine will rotate during this procedure. Start, select the crank, start main on, push the water wash start. So automatically this function will take place once completed, and you have to close this thing. So the water wash procedure with menu mode function: dry motor the engine, open the variable stator vents and close the variable bleed valves to allow the water wash mixer to more effectively enter to the compressor and clean the compressor hardware. This is very good to do this thing, water wash, because you can reduce the EGT margin with this. So this is schedule planning is there, there is a report for EGT accidents limit, then they will apply water wash procedures. So this task is done when cleaning the engine gas path with the pure water, non-detergent, or with cleaning solution. So this is purpose of water wash through the MCDU menus. We'll go through the next. Oil debris reset. This is very good information about oil debris system. We'll talk about the post mode. This option will be used to set the number of metallic chip that have been detected by the oil debris monitoring system for the cumulative count during all flight. I think in pre mode there was this detection was like each flight. Now they have used the word all flights. So this is the difference between pre mode and post mode count during the all flight. This value should be set to 0 when you clean or do an inspection of ODM chip, and set to previous chip count if you reprogram or replace the EC channel B, and not clean, do an inspection of ODA ODMS chip. So there is 2-3 condition. If you want to make this value should be set to 0 when you cleaning is done or inspection of ODMS chip is done. It should be set previous chip count if you are just reprogramming this EC channel B. Okay, so this function will be available only for channel B only. You will not find out in channel A. So whenever you need oil debris reset, you have to go through the engine, and then you have to select channel B. Only this function is available. Next is the fuel system preservation. Always you have to follow the MCDU procedure only. So everything is visual here, just like water wash. No need for explaining this. Just we'll go through the function. Function is to move the fuel system valve as the preservation fluid is added to the engine fuel system as a part of process for preparing the engine for storage, or you can say transportation. Preservation fluid is supplied to the fuel system inlet instead of fuel. So we are using preservation fluid in place of using fuel. So this will prevent the corrosion at all for the engine for long storage procedure. The engine is motored and master lever is moved on for the preservation oil to flow through the fuel system. Fuel system valve are then cycled to coat the servo valve with preservative fluid. So you can see this is the word coating of the component internally. This will prevent the corrosion inside of the component. That's why we are using preservation fuel in place of preservation fluid in place of fuel. So function need when the master lever is moved to off. So you just follow the MCD menu. Another function is nacelle anti-ice lock open. Nacelle anti-ice valve lock open function provides the ability to lock the nacelle anti-ice valve in open position. So you can lock through the MCD. In case of nacelle anti-ice valve is failed close failure for the dispatch purpose. So for dispatching, if it's found failed close, you can reopen the nacelle anti-ice valve through this MCD menu special function. Unlock the nacelle anti-ice valve from their open position. This option is used after a corrective maintenance action performed on the nacelle anti-ice valve following the valve close detection. So this is about the nacelle anti-ice valve. You can see nacelle anti-ice valve successfully commanded lock open position. This function also protection to prevent both nacelle anti-ice valve from being locked in open position at the same time through nacelle anti-ice lock open menu and losing the nacelle anti-ice function that could lead an overpressure at the inlet level. So this function have also protection to prevent the both nacelle anti-ice locked open condition because this will damage to the system. If the menu mode is enter on channel A, only the ability to check the upstream nacelle anti-ice valve for PRSOB1 is display. So if you are going for the channel B, you will find out for PRSOB2. So this is also good to know information about the nacelle anti-ice lock. Another function is discrete input check. You can see this nacelle anti-ice push button. Yes means either close or valid. If it is N number means it is not open or invalid. So I have mentioned this thing why and what is the purpose of this. The aircraft input check function in menu mode verifies the current status of the hardware, discrete and analog input from the aircraft. The function gives the operator the detail of the following: nacelle anti-ice push button function, auto thrust engage or not, auto thrust disconnection, thrust malfunction from spec relay, local cross channel throttle lever angle, signal value also you will get through this. So this is having discrete input function from the special function in LEAP engine. Another is accidents report. Already I told in water was why it is important. So the accidents report via menu mode provide the maximum value of accidents during the fan speed, N1 or core speed, oil pressure and EGT. Minimum value of oil pressure is also displayed. The operator may use this report to determine whether the engine exceeds operation limit and what is the duration of engine experience this accident. So you can say you can see this diagram. Suppose oil pressure maximum this, and you'll find the time of duration. So they have mentioned this is the limit approached and this is the time duration. So you can reset the value also, and you have to do necessary troubleshooting if this accidents report happen or reported by the pilot. Then another function is hydraulic pump depressurization. Here also you can see tests perform at idle speed, EDP pressure change during the test. You can follow the sequence. We'll go through this. The menu mode hydraulic pump depressurization test allow the operator to test the aircraft hydraulic pressure system by depressurizing the EDP while the engine is at idle. So engine is running, but we are depressurizing the engine driven pump, so to allow the operator to test the hydraulic pressure system. So this is the function of hydraulic pump depressurization. Then another function is engine balancing. Here also a lot of things are there: weighting, counterweight, balancing, balance. You can say I have not worked on this balancing related. We will go through the topic. The engine trim balance function allows the operator to calculate a fan trim balance solution using a vibration data from the previous flight leg on or ground run. Operator may select either the one-shot or advanced trim method. If a solution is reached, the operator is instructed to replace currently installed trim balance weight with the arrangement provided by the solution in order to reduce the engine vibration. The new solution may be saved the electronic engine control, non-volatile memory. So basically you are adding weight, removing the weight to prevent the vibration. Or suppose you have done fan blade replacement, there is some vibration during the engine run up, so you can add additional weight balance to sort out the vibration of the fan blade. Now the another question is that if the starter valve failed during the engine start, how many re-attempts are allowed for the pilot? So this is a scenario. Total 3 attempts FedEx will take care. Engine start fault, hot or hung due any reason, or ignition fault. In auto mode, FedEx will handle everything. So after first attempt, if auto failure of start happen, then FedEx will give another chance, another 2 attempts by both ignition A and B will be powered during this situation. So if first attempt failed during auto start, second and third attempt followed by the both ignition A and B. So this is good to know information about this. In case of valve is stuck, open or close or open condition, then you have to go with another procedure for manual opening of the valve for the starting purpose. So no action is required until unless ECOM advised to switch off the affected engine master switch. During this procedure, no action required until unless ECOM is giving some indication. Another question is reverse bleed system. Already I have discussed in my interview, one video I have uploaded for interview question, but once again we'll go through this. Reverse bleed system upgrade designed to mitigate fuel nozzle caulking carbon buildup. It reduced the cost on wing maintenance by the automatic calculating cooling air in the core after the shutdown, addressing the high soak back temperature. After engine shutdown, there will be the blower fan running sounding around the engine. So the concept behind this, previously this whole system was not there because engine was going well, but after some time there was on-wing maintenance, lot of fuel nozzle replaced, then further modification design, this reverse bleed system come into the picture. Now all engine is coming with modified whenever going for the overall, and some of the operator they are doing modification in own fleet one by one to recover all the fleet. So this is the reverse bleed system. You can see complete new assembly which is coming as a modification. There is a blower fan which will take the air from the core area to the reverse bleed valve. It will go through necessary check valve and it will go to the nozzle, fuel nozzle area. So this will blown out all the air from the nozzle area, because once engine is shut down there is a fuel vapor accumulation on the nozzle which will cause the clogging of the fuel nozzle. So with the help of this will blown out. So with the help of this, on-wing maintenance has been reduced with the some cycle. So this is having advantage using reverse bleed on the CFM LEAP engine. Now the next question is, why the anti-ice system not provided on the core of the LEAP engine? LEAP engine utilize a high bypass design where the large and composite fan blade are less prone to serve icing than earlier metal blade, allowing engine anti-ice to focus on the inlet cowl lip rather than the core inlet area. Furthermore, high temperature, high pressure 7th-stage compressor bleed air is efficient for the thermal and pneumatic nacelle anti-ice without needing the additional core protection. So because of the engine and blade, composite blade, no further requirement of anti-ice in the core area, but still they are using 7th stage of air for the nacelle anti-ice, because no need for core protection. So this is also good to know information. And construction about the LEAP engine. So construction of the engine, first we'll go through this. CFM LEAP 1 is high bypass 11:1 dual rotor axial flow turbofan engine for the Airbus 320 family, featuring advanced material like 3D woven carbon fiber fan blade, ceramic matrix composite for high durability. Key component including the 19 fuel nozzle, 3D printed fuel system, taps 2, and 3D woven fan blade with the titanium edge. So this is just general about the engine. Engine consists of the three major module: fan module, core major module, low pressure turbine major module, and the accessory driven gearbox. So in LEAP, this is only three main items: fan booster major module, core major module, and low pressure major module. In case of Pratt and Whitney, it will be totally different. If you want this about the Pratt and Whitney, go through my previous video about the interview question I have uploaded in that. Next is the TAPS, twin annular pre-mixing swirler. So this is a TAPS two type fuel nozzle using in the CFM LEAP, which is a advanced. We'll discuss about this. This nozzle are designed for high efficient lean burn combustion, reduce NOx emission by 50% compared to the previous standard. So this is very good to know information. They have reduced NOx emission by 50%. The TAPS2 system optimizes the fuel air mixer to improve the durability, enhance fuel injection and air fuel mixing to reduce the NOx emission, and lower operational temperature also reduced, contributes to a 50 to 20% reduction of fuel consumption. Always, if you are running airline, you should focus on the fuel consumption. Total 19 fuel nozzle used surrounding the engine in core area, and each TAPS fuel nozzle is surrounded by a radial mixer mounted on the combustion chamber dome. So there is a mixer mounted on the combustion chamber dome for this surrounded area. What is the function of MTC, modulated turbine cooling valve? So modulated turbine cooling system regulate the 10th stage of HPC compressor discharge pressure air flow to the first stage of HPT blaze root and internal blade cooling to optimize the fuel burn. So modulated turbine cooling, they are using they are using SPC 7th stage air. Modulated turbine cooling valve for the CFM LEAP engine. So next topic is modulated cooling valve of the LEAP engine. What is the purpose? So modulated turbine cooling system regulate the 10th stage of HPC compressor. They are reducing 10th stage of HPC compressor and discharging pressure airflow to the first stage of HPT blade roots and internal blade cooling to optimize the fuel burn. Because HPT is having high temperature, so they are using 10th stage of air, and this will blown out on the first stage of HPT blade roots as well as internal cooling to optimize the fuel burn. So this is also good to know information about the modulated turbine cooling valve. Another about the explain the ODMS system and how to check the chip count and perform the reset procedure. Already I have discussed. We'll go through once again. LEAP 1 oil debris monitoring system monitor the engine oil for the metal particle chips using a sensor that send the data to the EC. So through sensor, EC will get the data. Metallic particles are separated within the air oil separator and sent to ODMS sensor, further sent to the electrical signal pulses to the ODMS unit. So there is one is box ODMS monitoring system, and there is a unit installed on the oil tank. A certain threshold and level, the ODMS unit sends the signal to EC channel B that debris is present. So ODMS related, already I told it will be available on EC channel B only. So you have to go to channel B. You will not find out this option in the channel A. General, the ODMS consists of the following component: air oil separator mounted on the top of the oil tank, air oil separator, then ODMS sensor mounted on the side of the air oil separator. This is your ODMS sensor. ODMS signal conditioner unit mounted at the 4 o'clock position rear of the fan case. So this is the signal conditioner monitoring system which will give signal to EC. And reset procedure, already I have told, post mode. This option will use to set the number of metallic chips that have been detected by oil debris monitoring system for the communicated count during all the flight. Post mode in all flight, and this can be reset to the MCDU. So we'll not go through again. Now we'll discuss about the airframe, some question related DGCA. So airframe, which bleed air has priority, AP bleed or engine bleed? So APU bleed air has a priority over the engine bleed air when both sources are available. So if both sources are available, APU bleed air has priority. BMC will automatically manage the pneumatic system, allow the APU to supply the pack. So BMC will manage this situation about the priority. And some aircraft opening the cross bleed valve to supply both sides, reducing the load of the engine. You can use cross bleed supply for giving for the both sides. Which bleed air priority over the APU? Which bleed having priority, APU bleed or engine bleed? APU bleed air has a priority over the engine bleed air when the both sources are available. Suppose engine is running, still APU is on the bleed, then APU bleed will have priority. Once APU bleed is off, automatically engine will take care. So you can see this is the APU having priority. Currently we are using the bleed air from the APU. And BMC will automatically manage the pneumatic system, allowing the APU to supply the packs. So BMC bleed monitoring computer will manage all the situation to allow the operate the using pack. BMC will automatically manage the pneumatic system to allow the APU to supply the bleed air to the pack. So this is the scenario about the bleed priority. What are the electrical system priority? This also good to know. Everyone should know this thing. Engine Gen 1 and 2 when operating have highest priority over the APU generator over external power. So just for an example, you are giving engine run up, and once the engine is started and stabilized at idle, automatically electrical supply will go to the engines. That's why it's written engine Gen 1 and Gen 2 when operating have a highest priority over the APU generator or external power. Suppose you are running the engine with external power, then again it will switch to the engine Gen 1 and Gen 2. If you are running the electrical power with the APU, then again it will transfer to the engine Gen 1 and Gen 2. External power has priority over the APU generator when the external power push button is on. So just for example, you have connected GPU, you have pressed that external power push button on, and by same while you have started the APU, and you will see, if you see the ECOM, there will be the power supply through the external power only until unless you switch off the external power. So if push button, external power push button is on, APU generator will not utilize. APU will run ready to give supply, but generator will not utilize. APU generator external power, any one engine can supply the entire network. So this is also good to know. APU generator will give entire network, external power can also supply entire network, any one of the engine also will give supply to entire network. Just for example, one IDG failure. Backup. If one engine generator fail, APU generator can automatically replace it or other engine generator can take over. So just for example, we will compare with the example. Backup means what? Suppose both engine is running, suddenly one engine is shut down or IDG failure. Then other IDG will take over the command for the another side of the load. Or for example, APU is also running, both engine is also running, and during that time IDG is failed. Then APU will have priority in that particular means that side of failure engine. So if APU is running, both engine is running, then APU will APU will take the load of the failure IDG. So one side will be take over from the APU and other side will be taken care by the IDG. So normal configuration, we will go through the diagram, you will be happy. So this is your electrical pace. Suppose both engine is running, very happy, engine is enjoying, IDG is giving good supply. You can see Gen 1 with good load, Gen 2 is good load. So this is giving that this network, and this is supplying this network. Okay, we'll discuss in electrical chapter in detail. We'll just see what is the difference. Now you have connected external power. So external power can give both supply entire network. As I told, external power will give entire network. If both engine is off, external power is good enough to supply entire network. And if you talk about the APU can also give the complete network supply. Sorry. APU can also supply the complete network. External power also can supply complete network in both engine shutdown condition. In case of Gen 1 fail, both engine running but APU gen is not available, or APU is not started, then other generator will take care of the command. So you can see single generator also can supply both network. In case of APU is running, then this generator will give supply to particular site, and APU will take over a failure IDG. So this is very good to know information about this. Now, what is the function of the RAT? Under what condition does it deploy? This is also I have shared in my interview question, and we'll go through once again about this. RAT means ram air turbine. Is an emergency device that provides the hydraulic pressure to the blue system and electrical power to the essential flight control and avionics system. So RAT, this in emergency situation, this will supply both hydraulic power as well as some electrical supply for the flight control and avionics system. How it will deploy? Manual. There is a two procedure depend on the scenario configuration. So we'll go through once again in this video. If you're talking about automatic, if both AC bus 1 and bus 2 are lost simultaneously while in the flight, so RAT will deploy automatically in case of both bus 1 and bus 2 fail, or complete IDG, both IDG fail also, then it will deploy the RAT. In case of it's not deploying, there is an option. You press this, open the guarded switch, press this push button, and RAT will automatically deploy. Normally it will be in the auto condition, depend on this two configuration. From hydraulic panel main on. So hydraulic panel, you'll see there is a RAT main on. This is also guarded switch in case of dual hydraulic failure or other emergency. So from hydraulic panel only you will get hydraulic supply only. So and you have to select manually. So this is from the hydraulic panel about this. What is the function of leak measurement valve? We'll see there is a leak measurement valve. 3 push button are there, green, blue, yellow on the overhead panel top of the side. A leak measurement valve is a maintenance component commonly used in the aircraft hydraulic system, designed to isolate a specific hydraulic circuit on the ground. So this is basically to design, isolate a specific circuit, hydraulic circuit on the ground. It facilitates accurate measurement of the internal leak rate within the green, blue, yellow hydraulic system, identifying wear before the component failure. So before the component failure, they will identify the wear about the component. Hydraulic leak measurement valve is guarded. You can see partially guarded with the black. If already I have uploaded video about the guarded switch on my channel, please go through the video about all the guarded switch. If it is off condition, means you are putting the off, the corresponding electro hydraulic valve close, shut off the hydraulic supply to the primary flight control. So once you are selecting off, corresponding electro hydraulic valve will close, and this will shut off the hydraulic supply to the primary flight control. If it is on condition, corresponding electro hydraulic valve open to go back to the normal hydraulic supply. So this will be normally on. You have to select off to isolate the particular system. Now the next question is, what are the level of warning and class of failure in the 320 family? Where are the indication for the each type of fault display? So this is very good to know about. If you are engineer, you are going to approach the aircraft, we should know about this all the things. And about this already I have uploaded video for the post-flight report. Go through my post-flight report on YouTube channel. You will get more detail about the class 1, class 2, class 3 failures. So we'll go through once again here in quick, but we'll not discuss in PFR. A320 warning is categorized by the 3 level of urgency and 3 class of maintenance display on the ECOM. So level is different, classes is different. Classes is for maintenance, level is for the captain. So we'll discuss about the first, we'll cover about the level. So level 3, level 2, level 1. Higher the level means red warning, you have to take immediate action. So this is, that's why it's written urgent, requires immediate action. Example, engine fire. By the red master warning light, you will get continuous repeated chime sound you will get in the cockpit, red message on the engine warning display. That's why it's the red warning, level 3. Higher the level, higher the warning. Just keep in the mind, level 3. Level 2 is amber caution, require crew awareness but not immediate action, accompanied by an master caution. A single chime will come, amber message on the engine warning display. So single chime you will get, and here you will get continuous repeated chime. So this is the difference in red and amber, and you will get in amber light, and here you will get red master warning light. Level 1 amber can be white also. Status indicate loss of the system redundancy or maintenance status, require monitoring only. No no alert sound in the cockpit, usually display on the ECOM SD page. So we'll go through in this diagram, you will understand how it is. So you'll see level 3, we'll take the example of level 3 alert. You got the master warning. Okay, you got the master warning light, continuous repeated chime, specific sound, static voice also you will get. ECOM page affected system if exists. If there is some system, engine system is fail, automatically engine system page will pop out and you will get a warning message. And this is a red color. Now level 2 is amber color. You got master caution, here you got master warning. Okay, so caution message will be in amber color, ECOM affected page will pop out, you will get single chime only, not continuous chime. Then level 1 alert, caution message, here also that page if exit it will affected system will come out. And the status also you can press, you can see like some maintenance message or something you will get here. Now we'll discuss about the class 1, class 2, class 3 failure. So first focus on the class 1 failure. Class 1 failure are the most serious one, require immediate action, maintenance action subjected to the minimum equipment list. Class 1 failure have operational consequences on the flight. You can display the class 1 failure on the MCDU in the last or current leg report, last or current leg ECOM report. These faults are also indicated to the flight crew in the flight by the ECOM system upper or lower display by local warning in the cockpit. Refer if you go through the MEL, go, can be go if with condition, or no go. There will be the mention in the MEL. For MEL about MEL already I have uploaded video in my interview questions. Class 2 failure have no immediate operational consequences and can be displayed on the request to the ECOM system page under the maintenance title. You can display the class 2 failure on the MCDU by the last or current leg report, last or current leg ECOM report. Class 2 failure has required interval of 10 days go without conditions. So MEL can go and can be for 10 days. Then class 3 failure have no operational consequences. These faults are not indicated to the crew, but you can display the name of the system affected by at least a class 3 failure in the avionics status. So if you go in MCDU CFDS, you will find the avionics status page. You can find out that class 3 failure. Do not refer this MEL. Class 3 failure have no fixed time for correction. However, correction is recommended to improve the dispatch reliability. So no fixed time, but for dispatch reliability you can take corrective action. Class 3 failure may be corrected during the A-check program maintenance operation. So mostly class 3 failure will go for the C-check, A-check, heavy maintenance. They will take action during the A-checks or heavy maintenance. So as I told, class 1 operation consequences, class 2 no immediate effect, you can release under MEL. Class 3 will go for the schedule maintenance, A-check, C-check. So these are all the system. What are APPU? Asymmetric position pickup unit, and flap position pickup unit, and intermediate position pickup unit. We'll go through the definition. This is your position pickup unit. There is the flap position pickup unit also there on the wheel well area. So asymmetric position pickup unit, position at the tip to the torque shaft on the wing. These monitor the actual movement of the flap surface, comparing the left versus the right symmetric to detect the discrepancy. What are the asymmetric position pickup unit and flap position pickup unit, intermediate position pickup unit? The asymmetric position pickup unit position at the tip to the torque shaft on the wing. These monitor the actual movement of the flap surface, comparing the left and right symmetric to detect the discrepancy. So this will compare the both side of the movement. If any discrepancy is there, you will get failure warning. Flap position pickup unit located at the flap power control unit gearbox. It's measure the input shaft rotation to determine the command over all the flap. So this is a flap PCU will come here in the wheel well area above this PTU. Internal intermediate position pickup unit, similar function to the FPPU, APPU, but often used to verify the specific intermediate position, ensuring the immediate flap setting are accurate. So this is about the IPPU. So we'll just go through the diagram, we'll not go in the detail. We'll discuss in flight control chapter once we will come into the picture with this task. So this is your differential gearbox, pressure of brake. You can find out here flap position pickup unit, intermediate position pickup unit, and this is the asymmetric position pickup unit. So just for example, this is your asymmetric position pickup unit. Here is a asymmetric position pickup unit. If there is a movement difference between these two conditions, they will give a report to the computer, SFCC slat flap control computer. So same here also, if you will talk about the downside is a gearbox position pickup unit. Here also you will find out the asymmetric position pickup unit, and here also this is for flap condition. You can see flap 1 and 2, flap 1 and 2, and this is for your slat 1, 2, 3, 4, 5. Okay, so we will not go in the detail about this. We will discuss in another chapter. And there is a wingtip brake also. To apply the wingtip brake in case of failure happen to further movement, this will lock into the extended position, so that during flight or low speed, this will prevent the retraction of the flap slat mechanism. So wingtip brake is having good function into the flight control system. Which flight control in the Airbus 320 have mechanical backup? So this is also good to know. In Airbus 320 family aircraft, both cockpit pitch trim wheel provide the direct mechanical control of the THS via a cable system bypassing the electrical control. So THS is having mechanical function. This mechanical linkage allow the pilot to override the autopilot automatic trim system at any time, acting as a crucial backup, particularly in the direct law. So this will come like a normal law, alternate law, direct law is there. So this is the last situation. If you are coming into the picture of direct law, then this situation will come. And one more thing is just suppose you are flying with autopilot. Just a simple example, you are flying the aircraft with autopilot and you are just doing some movement with the throttle, or you can say side stick, then automatically autopilot will disengage, because manual will always have priority over the automatic control. So aircraft is flying automatically, let them fly automatically. If you are going to poke something, then it will come into the then it will come into the manual control. So always just keep in the word manual control, always having priority over the automatic control. That's why during autopilot no one will touch that system. The Airbus 320 yaw control uses a single hydraulically powered servo controlled radar. It is primarily electrically controlled by fly-by-wire system ELAC and FAC for yaw damping and turn coordination. But it also features a mechanical backup system connected directly to the paddles. So this is also having good to know information about the mechanical backup system on the radar. What are the flight phase? This is also I have discussed in my interview questions. Once again we'll go through the flight phase. So this is your flight phase. Pre-flight engine power on plus first engine start is first flight phase, and first engine start to first engine takeoff power is second flight phase. Third is more the aircraft speed is more than 80 knots. This will go to the third flight phase, and the lift off will go to the fourth flight phase. Once aircraft is lift off till 1500 feet, it will be climbing phase 5, then it will go 6 phase will be in the cruise, then further 800 feet once you are going, then 800 to touchdown feet it will come approach phase 7. Touchdown plus 80 knots, speed is reduced to 80 knot, it will go to the landing phase 8. Then 80 knots plus 9 taxi in, your taxi means it will 80 knots plus the second engine shutdown, taxi into the bay, you will this will come in phase 9. And 10 means after 5 minutes engine shutdown plus 5 minutes. So that's why you'll see once engine is off, you still you see FedEx is on in a simple way. So this all the 1 to 10 flight phase. This is also good to know information about, and you will find out in PFR all the fault with the flight phase only. So you should know maybe what is the flight phase 5, phase 6, phase 7, and all the class 1, class 2 failure will come into the PFR. Please go through my PFR video. Class 3 will not come into the PFR. What is the difference between A320 and 321 flap? So Airbus, you will see 321 there is a double slotted and 320 is a single slotted. The Airbus 320 use double slotted flap, whereas the Airbus 320 use single slotted flap. This modification 321 provide the higher lift to compensate for its heavier weight, because 321 obviously weight will increase, passenger will increase. So because of this they are using slotted flap for the higher altitude lift, and longer fuselage allowing for the better takeoff and landing performance, through its result in faster approach speed compared to the 320. So this is the concept behind slot. Now the next question is air conditioning system, how the temperature is controlled, modulated in the cabin and cockpit. So this is also good to know about the air conditioning system. So we'll go through this slide. This is your air conditioning system. Distribution is there, pressurization control is there, ventilation system is there. We'll discuss in different video one by one. We will focus here temperature controlling and cooling. So we'll go through this video till in. The Airbus 320 air conditioning system is a fully automatic dual pack system that manages temperature, airflow in 3 different zones, that is cockpit, forward and cabin. So there is a 2 pack. This will only manage cockpit, forward cabin, aft cabin temperature control. It cools hot engine APU bleed air through a air cycle machine that is packed and mixes it with the filtered cabin air using trim air to precisely modulated zone temperature. And other option also you can use external ground power, external air conditioning unit also option is there. So this is your air conditioning, just we'll go through the schematic. This is your in forward cargo, you will see this is the Y duct, this is mixer control unit, this is your HEPA filter, you can call Corona filter also. So we'll just go quickly in this schematic, how it is, how cabin is getting chill, how cabin is getting hot. So we'll go through here. There is a 2 computer, ACSC1, ACSC2, which is controlling all the situation of the air conditioning system. This is your pack 1 and pack 2. First engine bleed or APU bleed, where air will go through the flow control valve, it will go into the pack. Below the pack it will take tapping to the trim air pressure regulating valve, we'll discuss in the last. So a bleed air is going in the pack is doing work for what purpose it is installed, he will do our work. Then this will give supply, both pack will give supply the air to the mixer control unit. Mixer control unit is having cabin recirculation fan, it will use cabin air to reuse the same air, reduce the pack demand. So from mixer unit, this is your mixer unit, it will take 3 tapping, 1 tapping for cockpit, 1 for forward cabin, 1 for aft cabin. So there will be the duct temperature for this ducting, there will be the duct temperature sensor, you will see in the ECOM also. Then it will go to the cabin, so cabin zone temperature also you will see in the ECOM. And I have told you about this pressure regulating valve. Depend on the requirement, if you want to make the cabin little hotter, you can use this pressure regulating valve. that is hot air valve, and there is a trim air valve switch into the cabin. We'll discuss in the last video about the panel. Then you can control the hot air, you can mix with the cabin, so you can control the scenario in the cabin. You want to make it hot, you want to make it chill. So this is your pack unit. How in simple way, we will not go in the detail. Air bleed is going to the FCV. FCV is controlled by the ACS 1 and 2, and as I told, it will take tap from the FCV. It will take trim air pressure regulating valve tapping. It will go to primary heat exchanger. Primary exchanger will reduce the temperature. It will go to the compressor. As it is going to the compressor, again it will increasing the temperature and pressure, and from there there is a bypass valve. It will go and mix with the turbine forward area, and from the compressor it will go to the main heat exchanger. Further it will reduce the temperature because it is taking inlet air, and there is a water spray in the next stage, so this will increase the performance of the heat exchanger. It will go to the reheater. You'll see the reheater construction, how it is. There is a line and there is a casing, so it will go through the casing, it will go to the condenser line, and further condenser means it will absorb the molecules, and to remove the water molecule, water extractor is there. Same water is discharged into the inlet area of the pack from water extractor. Further it will go to the heater internal line. It will go to the turbine section, and temperature will be so chill. Again it will go to the condenser, and it will go to the mixer unit through the relevant check valve, and this bypass air is there. In case of temperature is more lower, then it will mix the hot air to prevent the ice formation in the particular location. So this is the diagram of Airbus 320 pack. Original, I have taken photo for just information. This is your inlet area of the pack. This is the exhaust area of the pack, and you will see air inlet area is this, and this is your bypass valve. This is your air cycle machine. This is your fan plenum chamber. This is your main heat exchanger. This is a primary heat exchanger. This is your reheater. This is your condenser. This is your water extractor. So this is the component, and this is the ram air outlet. Here in opposite I have used. This is your ram air outlet. This is your ram inlet. This ram air inlet, and this is your ram air outlet. So now we'll discuss about the ECOM bleed page and condition page. First we'll go through the condition page. So this is once you're pressing ECOM control panel condition page, you'll find out this display. So this display is for, we'll take the laser pointer. So cockpit, as I told you in the first slide, there is a zone cockpit forward and off. So this is your cockpit zone temperature, forward zone temperature, and this is off zone temperature. This two temperature sensor is there between the two overhead bin baggage above the passenger seat, and this is near to the third occupant seat, near below the 121 VUCV panel. And this is your duct temperature 21, 22, 24, and this is your trim air valve from the cockpit control 3 trim air valve cold to hot, and this is for the hot air push button. If you are coming in this page, so this page is basically this three you can mixer unit. It is going to the mixer unit. Cold air will go to the mixer unit, and this is for emergency ram air inlet, which is available near to the pack 1 area, and this is your pack outlet temperature. Pack outlet temperature is this. Lot of sensors are there, and this is cold or high. This is your turbine bypass valve, and this is your compressor outlet temperature sensor, and this is your pack flow, whether it is low or high, and this is your FCV. So this is general diagram about the bleed page and condition page. Now we'll discuss about the cockpit panel of air conditioning. So this will go one by one switch. We'll not discuss about the degree of rotation of the switch. So this is your pack flow switch control, low, normal or high. If flight aircraft is in flight, then it will be depend on the mode selector switch. Means you are in keeping on normal, you will get normal supply. If it is low, you will get low supply. If you will get high supply will be there. So in flight condition, if it is there is a one pack failure, then this any position of this switch will by default it will give high bleed supply. Okay, so they are with a single pack operation, you can say, or with APU also it will be in high only. So these three criteria will match only in the condition when the aircraft is in flight, then only this switch will work on low, normal, high, depend on the position. This is your pack 1, pack 2 switch. This will control the pack flow, pack on and off. And this is your trim, cockpit forward and aft cabin trim air wall. Talking about this wall what we have discussed. And this is your hot air wall. So hot air wall is pressure regulating wall is controlled from this. So this is interlinked with this all three. And this is your engine bleed. This is your APU bleed, depend what air you are taking from this area. So if you are taking engine bleed, basically this switch will be in the auto position. Once engine is on, then it will take supply from the bleed air and engine bleed. And if there is a fault, you will get fault light. If you want to select off or bleed enough, you can select off also, but provided you have to open this cross bleed valve open condition in case of you need cross bleed valve, cross bleed air. So this is for engine 2, same function. APU bleed will give supply to both pack at a time on ground. That's why it will be in the high, because high demand with the single unit. And this is your ram air inlet. Ram air inlet will near to the pack 1 area. There is a one panel. In case of emergency, you can use this switch. This is a basically guarded switch, ram air inlet. So yeah, this there is a purpose emergency ram air inlet open if there is a differential pressure is less than or equal to 1 psi. So guys, hope you have enjoyed this video till end, and I have given my best for my best of my knowledge. I have used a lot of materials. In case you need more video like this, please type in the comment box. Definitely I will share with you in next couple of days. Thank you so much for watching this video. Please hit the like and subscribe button for getting more Airbus videos.